In this section, we'll look at some of the characteristics of polynomials. The two key characteristics is that they are smooth graphs and they are continuous. So for example, a normal quadratic graph and sweep down and go up. You see that when I draw a polynomial, I don't need to take my pen off of the paper. This is a nice smooth graph here. If I want to draw a cubic graph, nice and smooth, it may come up and go down that way. That's a cubic graph. Okay, nice and smooth. I didn't take my pen off of the paper. Okay, and it's continuous. A quartic graph is similar. Up, down, it may come up again and go down again and go up again. So that's a quartic graph. Again, nice and smooth, except for here. That's my drawing, it's not very good. So come down and go up. So that's a quartic graph. But you may find a graph that comes down and has a hole in it. Okay, that's not allowed. So this is a hole. So that kind of graph is not a polynomial because it's not continuous. That would be called discontinuous. That's a discontinuous graph. This is not allowed. It's not a polynomial. A discontinuous graph would also be a graph that gets broken in one point and then starts in another point here. Like that. So this is not allowed either. This is not a polynomial because you have a gap. Have a gap in your graph. So this is a discontinuous graph. It's not a polynomial. Another kind of graph may come down to maybe the x-intercept, but then it will jump up like this. It'll go up and down like this. It's continuous, but it's not smooth. This is called a cusp. And this here is a corner. So this is not a polynomial. You may learn more about these in the future when you do calculus about cusps and corners. So this is not a smooth graph, even though it's continuous. In this section, we'll talk a bit about the number of turning points of polynomials and the number of x-intercepts that they have. Let's start with quadratic polynomials for the number of turning points. Well, quadratics either look like this or possibly upside down like that, aren't they? So a quadratic can have one turning point, okay? They can never have two. So, but they will always have one turning point. For cubic polynomials, just think about what they look like. So your most basic cubic polynomial will be y equals x cubed. Okay, this here is not a turning point. That's called a point of inflection. You don't need to know about that this year, but that is not a turning point. You'll learn more about this in grade 12 when you do calculus. So this case has 0 turning points. You may also have 2 turning points. How could that happen? You could come down, turn here, turn there. So in this case, this has 2 turning points. It's not possible to have one turning point in a cubic. So 1 TP, not possible. So either 0 or 2 turning points for cubics. So how about the number of x-intercepts? It is at most the same number as the degree of the polynomial. So if your polynomial is an x squared, you can have at most 2 x-intercepts. At most. So for example, this quadratic, in this case, you see there's no x-intercept. It doesn't touch the x-axis. Okay, so this has no x-intercepts. We could also have the case where your quadratic comes down and touches once. Okay, so now we have one x-intercept. This was 0. So this is one x-intercept. Your quadratic could also go this way. In this case, you'll have 2 x-intercepts. So for a quadratic, you can have 0 x-intercept, 1 x-intercept, or 2 x-intercepts for quadratic polynomials. So how about for cubic polynomials? The most simplest one is x cubed. So how many x-intercepts do we have? In this case, we have 1. In another example of a cubic polynomial, we may come down and touch the x-axis, then go up, and then go down again. So that's another example of a cubic. So we have 1 x-intercept, 2 x-intercepts. So in this case, we have 2 x-intercepts. In the final example, we may have 3 x-intercepts. So you may come down, 1, go back up, 2, go down, 3. So in this case, we have 3 x-intercepts. It's not possible to have 4. If we had 4, the graph would have to bend up again and go up. That would give us a quartic graph. Okay, so a quartic graph would have 4 x-intercepts, but not the cubic. The cubic, at most, will have 3, which is the same as the degree. So x power 4, which is a quartic, could potentially have 4 x-intercepts. Let's look at some examples of some cubic functions on Desmos. This is quite a useful website for checking your solutions when you do your graphs. Okay, the first one is x cubed. Let's take a look and zoom in a little bit. We can see that the line starts at the bottom, comes up through one point here, it bends and then goes up to infinity in this direction. So this doesn't have any turning point. This is actually called a point of inflection, which you'll learn in later in grade 12. So in this question, I've added 2x squared, and we can see the effect of the x squared on the graph. It will bend the graph here. So we have 2 turning points, 0, 0. The graph comes down, and another turning point is at minus 1.33 or negative 4 on 3 here. And the x-intercepts, we have 2, 1, 2 in that question. In the next question, we add an x onto the end. And similar graph, so it didn't change very much. We have a turning point now at minus 1/3. There's another turning point at minus 1. And it bends like that. So 2 turning points, and we have 2 x-intercepts, 0, 0, and minus 1, 0. In this question, we add a 1. So what happened here is the graph just shifted up. So we still have two turning points here and here, but now there is only one x-intercept down here. So this question is y equals x cubed plus 3x squared minus 2x minus 1. We have two turning points here, but now we have three x-intercepts. 1, 2, 3. Okay, so you see for cubics, we can have three x-intercept. Okay, this question only had one x-intercept. This question had two x-intercepts here. So for your x-intercepts, you can have up to 3 for a cubic graph. This question in blue had 2 in here, but the cubic y equals x cubed, your basic graph only had one x-intercept here. So for a cubic, you can have up to 3 x-intercepts. And at most, you can have two turning points. 1, 2.